Okay, good morning everybody. My name is Gusti Pangestu. In this presentations, I will present my research. The title is hand key points as features in hand gesture detections using concatenations key point transpose. Also, our research members is my supervisors, Mr. Dr. Yaya Heriadi, Mr. Dr. Alexander Agung, and Professor Widodo Budiharto. Okay, this is the word introductions. In the past decade, the number of people with hearing impairment has reached around 466 million people worldwide, and it is predicted that this number will increase to 900 million. In order to communicate with those people, sign language is very instrumental and fundamental. ISL, or the American Sign Language, is the most used sign language in the world. That's why in general sign language can be divided into two broad categories. The first is static sign language and the second is dynamic sign language. Unfortunately, most of the non-hearing impairment were struggling to understand the meaning of every word in sign language. So that's why one of the possible solutions is develops a language translation systems to translate sign language into speaker or written language, or maybe vice versa. To recognize sign language automatically, some prominent studies also have developed two approaches. First is utilize the sensors, and the second is using computer visions and image recognition technologies. So in our research, we choose the second approach is using the computer vision approach and image recognition technology. So this is our flow research diagram. We can see in here we have the hand pose image, and then we use the key point detections process. The key point detection process will produce a new data that contain a key point that mapping each point of our hands into the some coordinates x, y, and z. So all we call it the key point coordinate results, and then using those results, feature extractions process using the key point using the concatenations key point process, or we call it CKT. And after the feature extractions process, we also used to a next process we call the classifications process using deep learning, and then we have our system that called it hand pose detections. So what is the key point detections process? Key point, or also called interesting points, are special locations or point inside an image that represents what is interesting on the image. So in the image, we can see that our hand have several key points, and each of the several key points we're mapping and produce coordinate number, or we call it the x coordinate, y coordinate, and z coordinates. We have the three coordinates number. In this case, the hand is the main object that needs to be recognized and specifies the pose or its signatures. That's why we use the hand key points detections process. This research utilizing the Google Media Path API for key point feature extractions. There are several reasons why we are using or utilize the Google Media Paths. Our main reasons is the Google Media Paths is free tools that we can access, and we can also integrate these tools with many other language programming such as Python or anything else. So that's why we use the Google Media Path. And the second, Google Media Path proving their own ability and capability to detect the key points in hands better rather than any other model in several scenarios. That's why we use the media paths provided by Google. So, and then what is the concatenation k-point transpose? In the previous sections, we also explained about how can we get the k-point process by using the MediaPath. And then after we got the its k-points coordinates, we got the x, y, and z. We totally got maybe around 60 coordinates, 60 point, and its point we have the three values x, y, and z, and the concatenation k-point transpose, or CKT, will transpose this three-dimensional data into one-dimensional data. As we can see in the screen that previously we have some multi-dimensional of array contains the x, y, and z with the order number x1, x2 until xn, y1, y2 until yn, and z1, z2 until zn, and then we transpose those array, and then after we transpose, we concate one by one x1, y1, and z1, and the following followed by the x2, y2, and z2 until we got all of the hand k-point coordinates. So in the mathematical form, we can see in here the mathematical forms is contain the mu transpose. We ordered the coordinates from the x, y, and z, and then we also change it to one-dimensional data, from three-dimensional data into one-dimensional data. So we have extended line of the array, but we also decrease this dimensional shape of the array. And then after we have the CKT, or concatenation k-point transpose, we use the last process of our research. We call it the classification process. The classification process also is a very common process. We use some process from neural network or artificial neural network. So the classification process conducted in this research using the fully connected layer process, using the backpropagations. We know that a lot of neural networks architectures such as backpropagations, perceptrons, AlphaGo, and many more. But the most used one, or the most famous one, is the backpropagation process. That's why we use the backpropagation process, because this is the state of the art in the process of the neural network. And then the array obtained from CKT process was utilized as an input. So why we shape those 3D array into one-dimensional array? Because we want to utilize one-dimensional array into the neuron input. We all know that neural network process need the one-dimensional input as the input neuron. So that's why we change the three-dimensional into one-dimensional, because we want to use this array, those results or those coordinates into one as the features of the input neurons, as the features of the neural network models. And then the validation method used in this research is using several methods such as precision, recall, F1 score, and accuracy testing. And our datasets used in this research is the datasets that contains classified image provided by Anosal. We can search in the Kaggle usernames. This is free for us to access that. That published in Kaggle Kaggle. Sorry. This dataset contains around 50,000 images that are divided into 15 classes, including down, 8, 5, 4, left, 9, 1, right, 7, 6, top, 3, 2, up, and 0. The training and testing mechanisms was divide the datasets into two categories: datasets for training and dataset for testing. The size of each dataset is set to xt divided by 20 respectively. So this is the result. So we can see in the left side of the image, we can see that we have our datasets, image datasets. We can see the several signs of sign language, and then the k-point process detections are generating a new shape of data, or we call it the 3D matrix, that contain the coordinates x, y, z for each point in the hand. And then after we got the 3D mapping on 3D point or 3D versions of the hand K point, of the hand shapes image, we also use the concatenation process in the image, in the right image. We can see the concatenation process from 3D arrays into one-dimensional arrays, and then we use the one-dimensional arrays as an input features in the neural network process or backpropagation process. So this is the accuracy of our model. The loss is very, I think it's very good, because the validation loss are following the actual loss, and it's not far. The difference is not far too far. So this means that we are successfully to create a model that using the K-point features as the input in our deep learning model. And in the accuracies, we can see that validation accuracy that signed with orange color, the validation accuracy also increasing, and maybe nearly reached 100%, but it's little bit below the 100. So this is the accuracy and the comparisons with the other models. Our proposed models, or we call the GKT plus neural network, we can see that our proposed model achieve around the 0.92 to 8 or maybe around the 92% in accuracy, using the 50 epoch just like the others. And then we also see the input neuron size. The input neuron size is 60. Because why 60? Because we have 20 in x coordinate, 20 in y coordinate, and 20 in z coordinates. And if we sum all the coordinates, we have the 60 number. In the seconds, we try to decrease the input neuron from 60 to 40. We eliminate 20 from them. What features that we eliminate the z feature, so we just only use the x and y features. X is 20 and y is 20, and if we sum it all, we have the 40, right? And then the accuracy is a little bit decreased compared to the previous proposed model, that there are not any elimination at all. We have the 0.90003, or we have in the percents we have the 90% of the accuracy. Also, we compare it to the other model with the only CNN model, so we doesn't use the K-point detections as features, but we only use all the image, and then we just like the common CNN process, we do the convolutional network until we get the fully connected layer. The input neuron also increase from 60 or 40 to 128 input neurons. This is very huge, twice of our proposed model input neuron, but we have the accuracy around the 91%. That's why our proposed model achieve a higher results in accuracy compared to the CNN model. So our model proving that the input neuron, that the very limited input neurons compared to the CNN model that have a larger input neurons, our proposed model can produce the higher results compared to the baseline CNN model. So the conclusions is the research achieved a promising accuracy of 0.92 in recognizing hand gestures, which is very good compared to the baseline CNN that not using the key point as a features. And the proposed approach also demonstrates precision and recall rates of 0.95 and 0.96 respectively. However, this approach still requires improvement, particularly for applications with more classes to account for real-life cases. This research showed that hand key point could be used as an initial features for hand pose detection process that becomes the important part of sign language detection. So that's all I can present this to you all. Thank you for your time and see you.